So good afternoon. We'll continue with the discussion about modal analysis. I remember after modal orthogonality, nag-proceed tayo sa response spectra analysis. No? Here, we will show yung through modal analysis or modal superposition, yung benefits of modal orthogonality. No? Well, may recorded video na ako about this for the modal orthogonality that in order for this to be to be zero, no, dapat mag zero itong phi n transpose m phi r, no, kasi non-zero itong omega r square minus omega n square, no? For example, di ba, pag meron tayong mga modes, no, say for example this 5-story, we have mode 1, mode 2, mode 3, and they are not, of course, equal to each other, no? So therefore, may value yung omega r square minus omega n square. So since may value siya, therefore this is non-zero, no? So for this equation to be valid, itong phi n transpose m phi r ang zero. Okay? And this is, this is 1 if you have phi n transpose m phi n. Yeah. Or we call this the generalized mass, no? Generalized mass matrix kay Chopra. No? And this is also, yun nga, this is 1 if normalized yung modes, no? You will see that kay Chopra. Let's see. Saan ba yung modal orthogonality dito? Chapter, yeah. 1. There's a derivation. Tapos na yun. Dito, earthquake analysis today. Model expansion. Ayan, okay. This one. Or kay pass ko yata nakita yun. Anyway, ito naman siya. Okay. Yeah. So you will see this is M. No? Phi n transpose M phi n is the generalized mass matrix. Okay. For K naman, ganun din, no? Phi n transpose K phi n is yung malaking K naman. Okay. Now, let's proceed here. With that, no, magiging diagonal mass matrix na lang itong phi transpose M phi. Okay? But first, kung i-rewrite natin yung ating equation of motion, that will be mu double dot. Teka, mawawala yan dyan. So we have mu double dot plus cu dot plus ku equals, yun nga, let's say, so force sa function of time. No? And then, from this equation, no, the actual displacement is equal to a certain q, no, for multiplied by the eigenvectors, no? So we call that u equals phi q. So lumalabas itong q is the multiplier, no, to your mode shape. Diba? Remember, when we got the mode shape, for example, let's say we have this, ano nga, no, 5-story, we were able to find its mode shape. Okay? But that's not yet the actual displacement. No, that's not yet the actual displacement. So in order to get the actual displacements, we need this q factor, no? Okay. So in order to get the actual displacement u, then substitute natin siya dito. So we have now m. So u double dot will be phi q double dot plus c u dot will be phi q dot, no, plus k u phi q. Okay. Yeah. Next. And then sabi dito is let's multiply both sides, no, with phi transpose. Yeah. So when you do that, we're going to have phi transpose m phi q double dot plus phi transpose c phi q dot plus phi transpose k phi q. Yeah, no? Now, since we know that this is m, this is damping matrix, this is k, then we can call this as, say force, no? Right? Therefore, we now have this m q double dot plus c q dot plus kq. Malaking k na to, no? Lagyan ko na lang ng ano, ganyan. Force function of that. Na? Then, anong ginawa niya next? That's it, no? Or, no? This is already, no? This equation is already showing us that we were able to uncouple the equation of motion, no? Ito. Yan. Kung in-interpret natin to, we have this. Magiging diagonal matrix tong M, no? So C11, C22, C33, ganun din si K. So, let's say for example, itong pinakita niya dito is 2 degrees of freedom or 2-story, for example. You will see you have equation 1, equation 2, independent of each other. No? Okay, M11 Q1 double dot, no, plus C11 Q1 dot plus K11 Q1 equals negative N11 U double dot. Well, syempre itong this is just another representation ito. Phi transpose F. Kasi ground motion to, no? Yung force na dito. Okay? So that's it, no? This is two equations, no? This equation 1, equation 2, and uncoupled. No, we call that uncoupled equation. Sabihin, independent no? Independent yung response ng mode 1 sa response ni mode 2. Okay? So on so forth. Ganun din, no? Kung meron kang mode 3, mode 4, mode 5. You just have to get the responses of each mode, then sum up, no? Yung mga to get the total response. Okay? Now, let's try to solve a problem. Yan. I think na ito naman lagi natin gamit na problem. No? Nakaraan sa response spectra analysis, itong 5-story na tayo gamit natin. Sa time history analysis, ito rin yung gamit natin. And let's try to solve this using a harmonic force. No? Harmonic force. So, I'll write that again. So, let's say ito siya. So, ilan yun? 1, 2, 3, 4, 5. So, 1, 2, 3, 4, 5. Okay. Then, sulat ko na rin yung mga periods niya. So, ito yung mga periods. We have, I think na-solve na natin pala to. Ito na ba yun? Ito. Copying ko na lang ha. Yan, this one. No? Copy. And then, paste. So, yan yung mga periods niya. Meron na rin tayong SMAT niyan, no? Okay. Now, let's try na, let's apply F4 sa nyo gusto. Okay, dito na lang ulit. Let's say 30 sine omega bar t. So, lagay tayo ng force, no? Harmonic force at that location. Okay. So, we're going to find now yung response ni mode 1, ni mode 2, and mode 3, okay, mode 4, and mode 5. Ha? So, kukunin natin isa-isa yung phi transpose M phi kay mode 1. Ganun din kay K. Phi transpose K phi kay mode 1. And also the phi transpose F. Okay? Okay. That's mode 4, mode 5. And I highlight that. Okay. So we'll use our SMAT that we used last time. Saan ba yun? I think this one. Although nakaano to, no? This is in inches eh, no? Kasi this is patterned after Chopra. Okay, sige, let's continue. May essay ako nito eh. Lang. Ito na nga lang. Yeah, this is in SI already. So, yung 100 kips becomes 444 kilonewton, no? And this time our G is 9.81. No? And then remember, this is our check kagad natin the periods, no? To make sure that we're using the same data. You have 2 seconds, okay, 0.68, 0.43, 0.33, and 0.2966. Okay. So since consistent yung yung the period, no? So we'll follow this eigenvector or mode shape. So nilagay ko na siya dito. Wala pala. Yeah, this one. So remember, this is our equation that we're trying to solve the generalized mass for each mode. No? For mode 1, phi transpose M phi. Okay. Now, and this is my corresponding SMAT value for that. I-zoom in natin. Yeah. So remember, in SMAT, this is mode 1. No? So this is phi transpose. This is the mass matrix. And this is the phi. Okay? And it turns out this is our mass, no? For mode 1. And doing the same for each mode. So this is for mode 2, mode 3, mode 4, mode 5, so on and so forth. You will observe, iisa yung mass. No? Kasi nga, the mass per floor is the same eh. No? So, sulat na natin yan. 45.2599. So, that will be now 45.2599. So, they're the same. Ganun din sa mode 3. No? 25 pala, no? 2599. Sorry. So, this should be 45.2599. Okay? Now, how about the K? No? Same formula. One here. Yan. Okay. So phi transpose. So this is our mode 1 again. Phi transpose K phi. Then you'll have this. So for mode 1, I have 446.54. Mode 2, 3804.73. Mode 3, 9454.915. Mode 4, 15603.195. Finally, for mode 5, 20,297.54. How about the force? No? For the force, ito naman. Phi transpose, yeah? Phi transpose F. No? But ano ba yung ilalagay natin force? Say yung 30, no? 30 kilonewton. So I'll change this into 30. Make this 30. Phi transpose the force. So that's 17.906. Okay. 53. Mode 2, negative 16.456. Mode 3, negative 13.672. In mode 4, negative 9.78. Zero 6. Mode 5, negative 5.09674. Yan. Yan. So ito siya. So quickly, no, let's try to to absorb, no, what's happening, no. So basically this parang this generalized mass and stiffness, no, parang in-idealize niya into an SDOF, 'di ba? Yung bawat mode, no. The MDOF becomes an SDOF. So for example, let's substitute yung period, no. 2 pi square root of m 45.26 divided by k 446.54. Tignan nyo. Ayan, no? For mode 1. No? Oops. Okay? Then when you substitute that, what do you get? You will basically get a period of 2 seconds. No? Which corresponds to this one. No? To what we got, no, in our eigenvalue analysis. Parang kinonvert niya, no, yung yung mode 1 into a mass and stiffness, no, to come up with this period. So yun yung ginagawa niya. So once we have that, kukunin na ngayon natin yung mga response, no, yung, well, time history response ng bawat mode. No? For example, so let's, okay, punta ngayon tayo dito sa STAAD natin. Let's subject that to the force. So, 30 kilonewton. So, sine omega bar T. So, what omega bar do we want? For example, so let me review first. Ano ba yung omega bar nito? Or sorry, yung omega, no? Frequency ng bawat mode. Yan. So, ito yung frequency ng bawat modes. I'll try to write that here to give us an idea. So, omega is equal to, so meaning the natural frequency. So, this is 3.141, 9.17, 14.45, apat lang to. 18.567, and finally 21.177. So let's choose an omega bar of, let's choose an omega bar near, for example, near mode, what do you want? Mode, mode 2, no? Near mode 2. Okay, 9.17. Okay. Assume omega bar 9 near mode 2. Say 10. Yan, 10 na lang, no? Say omega bar 10, no? Okay. So, anong cycles yan? So, 30 sine, what's that? If I convert that, 10 equals 2 pi so that will be 10 divided by 2 pi. Kasi one cycle is 2 pi. 1.5915. Yeah. 1.5915. Okay? One point. 30 kilonewton, say, assume tayo ng 5 cycles lang para maiksi lang. Then, modify, yes, close. And, undump tayo, no? Where do we, ito siya. Then, lagay natin dito sa taas, no? Applied here. Okay. So, save. Then, analyze, run analysis. Post-processing, dynamics. So, the same period. Dito tayo sa displacement. Yan. So, this is the displacement at the roof. Yan. So, we have a maximum displacement of 28.4. No? So, I'll ano, no? So let's record that. 28.4 at 2.31 seconds. Now, how about sa fourth floor? 15.3 at 2.33. At 2.33 seconds. And here, 18.6, no? At 2.6. At 2.6 seconds. 28.1 at 2.6 seconds din. 28.1 at 2.6 seconds and 20.1 millimeter at ano to? 2.62 seconds. Okay. Okay, how about okay, say alam this one. So ito yung spreadsheet natin last time. Yan. Ginawan ko na ng SDOF representation. Okay, okay. Now remember, ito yung nasulat nating mga mass, no? Generalized mass for mode 1, 45.2599. No? So, nilagay ko na siya dito. 45, dahil naka-Newton yung spreadsheet, 45,259, no? 0.93. Then the K is 44654. Oh, bali 540 kasi nga Newton per meter. How about the force? No, it should be 17,906.53. Palitan ko to. Ano? 17,906.53. Then ito na yung time history response, no? Ah, by the way, ano yung omega ko pala? Ano yung nilagay kong omega? Is 1.5915. 1.59. Yan. Yan yung nilagay nating omega or cycle, no? 1.5915 sa STAAD, no? And this is now the time history response, no? Of a 2-second SDOF. Okay? So, nagawa natin ito nakaraan, no? Pero ngayon, naka-specific sa 2 second, no? Kasi nga, yun yung mode 1 natin. Okay. Okay, so i-verify muna natin itong response ng roof 28.4 at 2.31 seconds. 2.31. Nasaan si 2.31? Laki pala. Ang haba pala, wait lang. Teka. Ano bang magandang 2.31. Sige yan. 28.4 2.31. Sige, dagdagan ko to ha. 2.31. 1.7 pa lang. Ayun. So here, ang response ni 2 seconds sa 2.31 second ay 1, 2, 3. 15.47. 15.48 na lang, no? Millimeters. No? So, kay mode 1, sulat ko dito, 15.48 millimeters at 2.31. Okay? Sinulat ko. So, under 2 seconds yan. Next, punta naman tayo sa mode 2, which is 0.68. Okay, 0.68. Ito, no? 0.68. So, double check natin yung ano, yung mass. Yeah, the same, 45.259. Ito. Yan. 45.259. K, 3804,730. Yan, the same. Ito yun, Yan, M and K. And the force should be 16,456. Ulitan ko to. 16,456. Okay? For mode 2. At 2.31, wala pa. Ayan. According kay mode 2, you will get at 2.31, 2.6 or 2.57 millimeters. Okay. 2.57 millimeters. At 2.31. Okay, that's mode 2. Okay. Mode 3. Mode 3 is 0.42. Let's check. The mass is still 45. Yan, 259. K, 9454, 910 or 915 dito. Yan. Force, 13,672. Negative, no? Negative. Negative 13,672. Okay. So still, and then at 2.31, okay, at 2.31, we got 1, 2, 3. Negative 3.36 millimeters. Negative 3.36 millimeters. Okay. Mode 3. Mode 4. About mode 4. Okay. Yan. 45,259, 15,603, ano to? 9,780.6. Negative 9,780.6. So that's the force. Okay. At 2.31. To 9.72. 9.72 mm. At 2.31. And finally, mode 5. Okay, let's check. Yeah. So mass is the same, 45,259 K, 20,297, 540, and the force negative 5,096.74. Okay. Yeah. 2.31. Okay. Yeah, I'm getting negative 0.53. So halos wala na siyang effect, no? Negative 0.53. 2.31. That's it, no? Well, now when we add up all that, what do we get, no? Yeah, so ito yung summary at 2.31. So I add 15.48 plus 2.57 minus 3.36 plus 9.72 minus 0.53, and you will get 23.88. No? May konting discrepancy. No? So we're getting or 24 mm at 2.31. Okay? So that's the well, the modal analysis. No? Just add up the responses of each mode. So, but it doesn't mean na yan yung that's the maximum. Doesn't mean na yan yung maximum. Okay. I think, wait lang. Di ba pala tapos? Okay. Di ba pala tapos? So that's only the Q pa lang, no? That's the Q pa lang yun. So here, ayan. Okay, ito. So I'll try now to input that here. So input ko si 15.48. And then 2.57, like this one. 2.57. Negative 3.36. 9.72. Okay. this ano? Okay, so update ko din pala to. I forgot. So this should be 1.5915. This is 1.591. Remember yung time history we did last time is during ground motion, no? This one is a modal analysis, no? Under harmonic force. Yeah. Okay. Then let's update. 2.31. 0.14. But should be 0.37. Uh, 4.25, no? 4.25. Node 2 is ano to? 38.48. Okay? 38.48. Ito, tama na to eh. Kasi updated yung frequency nito. 15.48. Ayan. So, 15.48. So, strip natin dito. And this one is 38.48. And then, ito, 4.25. 0.37. Okay. 0.14. Maybe ito may discrepancy lang to na ano. 15 and 38. Paras mo silang positive. Okay. They're both positive. Ayan. Updated ba yun? Ano? Yung aking ayun vector. Copy ko to. Copy this. Then paste here. Anyway, ano naman, no? When you add this all, ito. So 9.24 minus 21.11 minus 1.93 minus 0.12 minus 0.024. I'm getting 14 mm. Maybe because this is more on sa, what do you call this? Masyadong close yung aking spacing. Point lang no? 0.01, no? 0.01. Oh, ba? Yeah. 0.01. Let me check. Okay, double check natin. No? Negative si mode 2, negative si mode 3, negative si mode 4, negative mode 5. Okay, correct. So the sign, no? And return to mode 2. Ayan. It should be negative, no? Negative 38.48. Okay. So I'll make this negative 38.48. Yeah. Okay. So pansin nyo na, when I change the value into negative 38.48, naging positive na siya. No, naging additive na sila ni mode 1 and mode 2. Okay. Nakita ko the values are already close to each other, no? Kasi sa signs, no? There's a discrepancy on the signs. Okay? So, basically this is now the displacement at 2.31. That's it. Yeah, this vector, no? Displacement vector na yan from each mode, no? Contribution by mode 1, by mode 2, by mode 3, by mode 4, by mode 5, no? At 2.31 seconds. Kasi yun yung kinapture natin, no? That's what we captured earlier. Okay? So for example, these are the values at the roof. Huh? Yeah. So when you add up negative, 9.24 plus 21.11 minus 1.94 minus 0.12 minus 0.023. So now I'm getting 28.27, which is pretty close kay STAAD, no? STAAD gets 28.4, no? Ito siya, at 2.31 seconds. Okay? Okay, so let's recall what we did. So basically, again, we got the maximum, hindi maximum response, no? The time history response of each SDOF, no? Treated of each mode shape treated as, or modal period treated as an SDOF on a certain time, no? 2.31 in this case, no? Then nilagay natin sila dito. These are the responses of that modal period at 2.31. So basically, this is the implementation of U is equal to phi Q. Yeah, no? We were able to get Q, the responses from each mode. Then this phi transpose, yan na yung mode shape, no? Multiplied to the response of each mode. Then with that, you will be able to get the displacement na from each mode naman. Okay? So that's how we implemented the modal analysis, no? Again, it doesn't mean na yan na yung maximum response, no? We just captured the time history response at 2.31 seconds, no? And this is the summary. Sinulat ko na kanina, no? 28.4 at 2.31 second. Then remember, our omega here is what? 10. Omega bar. No? Omega bar. Then let's compare. Then we really intended that to be as close as possible kay mode 2, which is 9.17. Na? We really intended that to be as close as possible kay mode 2. Meaning, we force, no, we applied a harmonic force to the MDOF, to the 5-story, exciting, no, the mode 2, no, which means the response of mode 2 will be amplified, no, or siya yung ma-excite, no. And let's see if that happens, no. If you will see the summary here, tinan niyo, kanino ang may maximum response at that time period, di ba? Mode 2. We were able to see that the maximum response is at mode 2. Yeah. 38.48 millimeters. No? At 2.31. So, siya talaga yung na-excite. Okay? So, it means, if babaguhin natin yung omega bar, such that, say, close to mode 1, siya naman yung may maximum response. Kasi siya yung na-excite na mode, no? At that time period. Okay? Because of this omega bar. Okay? Now, in getting the maximum response, so similar to, this is what we did is similar to time history, no? Underground motion, no? Ito, time history under harmonic excitation, no? Now, to get the maximum response naman, parang analogous to response spectra analysis, same procedure, no? You just have to get the maximum response here, no? In each mode. Hanapin mo lang yung maximum response. No, sige, tingnan natin. If if we, what do you call this? If we check the time history, no? Pero for me, ang shortcut na lang siguro is the shortcut will be change natin yung cycle. Let's try to change the cycle. So instead na 5 lang, gawin natin siguro 30. No? Then during the time history, let's check if we achieve the maximum response. No? Analysis. Run analysis. Post-processing. Okay. Then results, placement. And so si roof, we got a maximum response of 35.9 at 11.5 seconds. So medyo matagal, no? It needs more than 10 seconds to get the maximum response. Anyway, let's try, no? 11.5, so maximum response. 35.9. I'll write that down. Max response 35.9 millimeters at 11.5 seconds. How about the second floor? Take note, no? Take note, this harmonic force is is in resonance or almost in resonance sa mode 2. And we got 17.6 at 12.4. 17.6 at 12.4. Okay. 18.8 or 19.7 at 3.6. No? At 3.6 seconds. And second floor. Mataas din to. 31.9 at 3.6 din. 3.6 seconds. And finally, sa first floor, 24.2 at what time? 4.58 seconds. So, meaning, what happens? No? Ang max pa rin response is 35.9, no? Ito, nandito sa roof pa rin, no? Nasa roof pa rin yung maximum response. Okay. Makes sense kasi mode 2 is just ganito lang naman no? Parang ganyan lang naman, no? Okay. So possible nandito pa rin yung maximum response, no? I'm guessing it's either sa roof or dito sa what they call this sa second floor, no? Sa fourth floor. So 35.9. Okay. And you can see at 11.5 seconds. So what we do now is check the time history response of each mode. No? Tingnan natin yung maximum response. Okay? So sa 2 seconds, and meaning nasa vicinity ng 11 seconds. No? Kasi this is the summary. If I will show you, yan, ito yung summary of the maximum responses. Assuming na-cover na natin yung maximum response, no? You will observe the maximum response is at the vicinity of 10 seconds to 15, no? If you consider this 31.9 very early, 3.6. So let's stick around 10 to 15 seconds. No? Let's check. So meaning we'll extend the time history here. No? Nitong mode 1. No? Let's check kung ma-achieve nga na yung response na yun. So, medyo mahaba to. Okay. Yeah. So, it's there. Yeah. So, 13.42, pwede na siguro to. Then, I'll change the, ano na, itong cover nito. So, that will be J24, ano? 244 up to, anong address? 1348. So, babaguhin ko, no? I'll change this to 1348. 1348. This one also is 1348. Ayan. Ano siya? Which means, medyo ano na nga, cyclic, no? And around here, no? Ito yung max, no? 1, 2, 3, 18. 18 mm. This one, ano, wait lang. Oh, but never exceeded, ano, 20, no? Never exceeded 20. Ito is 18 also, no? This is all 18 also. Ito, 18. O, 18.3. Yan, no? Between, ayan, 11.47, 18.3. Yan. I can write this now. 11.47, 18.3. Write that. At 18.3 mm at 11.47 seconds. That's mode 1. No? That's the maximum ano niya, response. Alternatively, you can check yung dynamic amplification factor natin na graph, no? Having omega bar over omega, no? Pero mas sure ako dito sa ano. So mode 2, ganun din, no? Let's extend the ano, no, the duration at more than 10 seconds. Ayan. So 1263 naman siya. 1263. This is mode 2. I'll change the address up to 1263. 1263. Okay. Ayan. And you will observe a cyclic, no? May cyclic nga siya, no? So, ibig sabihin, enough na yung na-capture nating, ano yan, 1.5 cycle na yan. No? That means we've already covered the maximum response. And obviously, the maximum response of mode 2 is here. At 3.62 seconds, 47 mm. No? 347.14 mm at 3.62 seconds. Okay, this is write down, this is mode 1, this is mode 2. Ayan. Okay, 18.3. Okay. About mode 3. Ayan. So, cover din natin up to 10 seconds. Let's check if the yan, 1231, the address. Mode 3. This is now 1231. Yan. And you will observe cyclic pa rin, no? And by inspection, the maximum response is Maybe here. Ito na rin yun. 1, 2, 3, 4. 4.64. No? Nandun lang naman eh. No? 4.64. Yung max min niya, around 4 lang din naman eh. 4.64 at 0.77. At 0.77 seconds. So that is mode 3. And mode 4, about mode 4, Mobra 1158. Okay, I'll change this to 1158. Yeah, another cyclic pattern na naman. And obviously, just ano lang, more than 1 mm lang, no? 1.4. This one, yeah, 1.4. Yeah, 1.4 na lang. No? At time 3.3 seconds. At 3.3 seconds. Obviously, you will see na very dominant talaga si mode 2. No? So, comparing the 4 na lang, no? Kahit wag na natin tuloy sa mode 5. No? Mode 1 is just 18.3 millimeters. Pero si mode 2, ganun kalaki. No? Kasi nga siya yung na-excite na mode. In resonance na halos yung frequency ng force doon sa mode 2. 47.14 millimeters. Okay? Siguro, hulaan na lang natin si mode 5. Late na lang natin, no? So, if you talk about parang maximum response, no? Maybe, where do we, ano? Ano ba siya siningit? What's that? Maximum response. Sige, I'll just copy na lang to. Copy this. Control C. Ano naman akong binago pang ano, no? Then, move ko lang to. Then, paste here. Ayan. For maximum response na analogous sa response spectra analysis na ginawa natin, then I'll, yeah. I'll 18.3, no, for mode 1. Ayan, natin. Yeah. Natin. 18.3, next 47.14. 47.14. Next 4.64. Ay. Yan. And last 1.4. Litan ko na lang si mode 5. Wala na lang. Ayan, pwede na 0.14, no? Wala namang ano yan. Okay. That's it. So, this time, what I input to the Q is the maximum response, no? Then ito na ngayon yung mga, this is not a realistic displacement, no? Kasi nga from the maximum response yan, no? We'll just do the SRSS, no? So square root of, saan ba square root dito? SRSS response, ano ba? SRSS underscore response, yan, is equal to the square root of, sana, square root, yan, of 10.92 here, no? 10.92 square plus, ito, 25.86, no? Square plus 2.11 square plus 0.456 square and then plus 0.024 square. Yeah. So ito na yung SRSS response, no? Doon sa roof. And when you check its value, I'm getting 28, no? 28.15, no? 28.15. Laba akong na ano? 25.86. Okay. If I make this 2, for example, okay, ito sa roof, no? How about sa saan ba? Sa second floor. Ito. Second floor. Si, copy ko to. Control V. Gawin ko tong 2. No? 5.97. Again, ano to SRSS lang to. Ano? 28.14. 0.79. What else? 0.64. 64. Then 1.1. Control C, Control V. Meron din, no? 28.8 din, no? Halos hindi nagkakalayo. So that's for second floor, no? While I'm getting 31.9, no? Sa STAAD. Okay. Maybe this should be, ano? Hindi, tama naman. Okay. Uh-huh. Continue ko lang itong mode 5 saglit para complete. Okay, 1, 3, 12. Ito. Like this. 1, 3, 12. Ito, malaki din pala to. 0.4. 0.4 lang din pala. Point 4. This is 1 point something. Okay, so that's your SRSS, no? And makikita nyo, no, you will observe yung max response niya nandun sin sa between 11.5 and 12 seconds, no? Which is pretty close dun sa ating here. Yeah. 18.3 is at 11.47 seconds also, no? Okay. Yeah. 11.47 seconds, no? But this is from mode 1, no? And according kay SRSS, that's with what we did, we get 28.8 or 29, I don't know, yeah, 28.4, no? mm, no? By combining this maximum responses. Okay. Then for second floor, max response niya or fourth floor, biglang bumaba, no? 17.6 mm lang, no? Okay. So you will observe by the summary, no, that si roof pa rin yung may maximum displacement, no? Kasi pag ganun din naman yung mode 2 eh. Okay. But although si roof yung may maximum displacement, you will observe yung contribution ni mode 2 is malaki talaga, no? Malaki pa rin, no? Malaki yung contribution ni mode 2 because if we will use this for the fourth floor, copy ulit natin to for the fourth floor. Kunin natin yung response niya. 10.04, 10.04, 8.1. Yan. 1.5. 0.5, 0.84. Ano pa? Okay, wait lang. Ito lang, baka may ano. Kailangan ko palang palitan to. Gawin ko tong S Baka kailangan ko palitan to. S. Yan. Itong S. Para consistent. Kasi, basta na lang natin kinopy-paste yung ano eh. Yan. Meaning SRSS. Anyway, wala naman nagbago. 26.1, 2.11, at least consistent. For the fourth floor, 10.04, 8.1, 1.5, 0.84, 0. Teka, this is only 0.4. 0.18. 0.18. Copy ko to. Paste here. Equals. Yan. I'm getting just 13 mm. No, maliit talaga. Ibig sabihin lumiit. No? Mas malaki pa rin talaga yung maximum response ni yung trend you will observe. Mas malaki talaga yung response sa roof talaga. No? Kay fourth floor, 13 lang. No? And then pagdating kay second floor, makikita nyo, lumaki rin talaga. No? Yung response niya, which is consistent with what we observe kay STAAD. No? Mas lumaki bigla. No? From 35.9 sa roof, 17 lang sa biglang baba, almost half sa fourth, then mag-increase konti sa third, then lumaki ulit kay what they call this, kay second floor. Which is typical kay mode 2 talaga. Di ba? Pag ganyan yung shape ni mode 2 eh. So, ito yung nag-contribute. Okay? So, that's it, the SRSS approach, no? Maybe, let's try CQC. No? Lang, hindi nakita. Okay, and again, roof has the highest displacement pa rin, 34.8, which is consistent to what we got here. 28 naman siya. Then pagdating on the fourth floor is just 13. No? Consistent dito, fourth floor, biglang liit. Okay? 17 lang siya. But also on the third floor, 18.8. But on the second floor, 31.7, which is consistent with what we got here in our SMAT using SRSS. Ayan. So this one, 28.8. Almost the same sila ni roof and second floor. Okay? And take note, yung time that when the maximum response occurred, between 3.6 seconds, no, and 4.58, which is the same time na nag-occur yung maximum response kay mode 2, no? 3.62 seconds. Okay? And that's mode 2. So, makikita nyo yung contribution ni mode 2 is really dominant, no? Because again, the applied force is almost in resonance, no, with the natural frequency of mode 2 of our structure. So that's your modal analysis, no? We were able to analyze, no, to independently each mode and then combine their responses to get the total response, no, of our structure. Okay. Kayo na lang mag-supplement ng CQC, no? Because there's a tendency, no, na mag-close si CQC, no, tsaka yung dito sa response natin sa, because si CQC as per Chopra, I think dito na mention dito yon na there's a tendency na magtugma, no? There will be mas useful si CQC when the modes are close to each other. Okay, when the modes are close to each other, there's a tendency that CQC is more preferred, no, than SRSS. Anyway, that's the parang technique to to combine the responses, no. But I've shown you the time history response also, no. Yun yung mas accurate, of course, because that's the time history response, no. But ang benefits of SRSS and CQC, you don't need the to compute the time history, no. Kung may time history ka ng each SDOF, no, mas madali mong very easy mo ma-compute yung maximum response, no. Pero statistical combination yung ginagawa. Yun nga, it's either SRSS or CQC. Okay. Questions? Ano bang ano natin? So yan, so meron na kayong harmonic force, na-apply nyo rin sa earthquake, no, and response spectra. I-recall ko lang, no, paano na-derive yung participation factor, kasi Chopra is the approach of Chopra is not obvious, no. That's why I get this screen grab, yan, from NPTEL. Yan. So you will see dito lalabas yung mass participation factor. Not mass participation, but rather just the modal participation, no? Modal participation factor. Okay. Mas na-derive to mas pinakita ni Mario Paz, no? Where is Mario Paz? Ito na lang. Kasi the modal participation factor is used, no, dun sa under earthquake response, no. Where's that? So force motion, base motion, ito. Yan. Yan. So dito siya lumabas. Yan, participation factor. But you will see yung derivation niya is still yung kagaya ng ginawa natin, no. Ito. Yan. So meaning this participation factor is this one. No? And actually this is basically phi transpose M divided by phi transpose M phi. Right? Yan lang yon. And in our notation earlier, this one is the generalized mass. No? Okay. So ito din yon. Okay. And if you simplify that, remember in this presentation naman, yan. Ito kay SK Gosh, yan, this one. Nire-relate ko lang doon sa past lecture para ma-connect nyo. Yan. Nakita nyo to, itong formula na yan. Yan. You will observe this formula of L is actually this. Phi transpose M. No, kasi ito, W over G is mass, no? So basically, yan yung phi m. Phi transpose because vector to ano no? What do you call this? Transpose of the mode 1 or mode eigenvector to the scalar m. No? Yan. Kaya phi transpose m. Ito lang yun. Then this m phi square is this one. Phi transpose m phi. Right? Ito is basically phi transpose m phi. Okay. Hindi yan obvious kasi kay Chopra, no? Hindi ganyan yung presentation ni Chopra. And ganon, kay SK Ghosh, ganito ng presentation niya. Kay Mario Paz is this one. And so, but yun nga, I'd like to remind you na they are the same, no? Yun lang din yan. Okay? Mas maganda kasi na may participation factors because nakita mo yung contribution nga of each mode, no, to the earthquake response. Yeah, let's try to derive, no? If we use phi transpose m, no? Let's say yung convention niya kasi ng eigenvector is A11, A21. So basically, this is A11, A21, that's phi transpose m. So M1, M2. Right? So this is 1 by 2. This is 2 by 2. So compatible, right? So you will get a 1 by 2 matrix, which is this. 1 by 2 matrix. So A11 times M1, right? Okay. Plus A21 times 0. Kasi nga, row column, no? Plus A11 times 0 plus A21 times M2. So, lahat to. So, matitira is this. Which is still this one. Okay, so that's your phi transpose m. Then how about this one? Phi transpose m phi. So I'll rewrite that here. A11, A21. That's your phi transpose. M is M1, M2. Then your phi. So A11, A21. So this is your phi transpose m phi. So if we do this first, we got A11 M1. So diba this is 1 by 2, 2 by 2. You will get 1 by 2. A11 M1 and then this is 2 by 1, no? Yan. A11 M1 and then A21 M2 multiplied by A11 A21. So ito na yung 1 by 2 natin. And then this is your 2 by 1. Then you will get a 1 by 1, no? 1 by 1 as a result, no? So that's it. So A11 M1 A11 plus this one A21 M2, then this one A21, no? And this is the same, so kaya naka-square siya, no? And this is the same, Kaya naka-square siya. Okay. Yan. Sorry. Ito pala. Nas mode 1 lang pala ako. A11 square, then A21 square. See? So, that is your phi transpose M phi. Okay. So, this parang ano siya, no? For me, to reconcile the concept, no? Applicable si participation factor because the variation of the distribution of the force, it's because it's an inertia force. The ground motion is an inertia force. So ibig sabihin, na-excite yung mass, no? Kaya kailangan mong makuha yung participation factor in relation to the masses, no? Unlike what we did here sa yan, hindi yan ground motion, right? So kaya straightforward modal analysis ginawa natin. We did not get the participation factor. Kasi nga the response is dependent on the force, no? The force, no? Unlike the ground motion, ang na-excite sa ground motion is the masses, eh, no? Kaya you can achieve or you can kumbaga, that's why it's wise to get the participation factor relative to the masses, no? And of course to the eigenvector.